We are going to do assignment 5.1 today, and it deals with trigonometry. Trigonometry is the study of how the angles in a triangle affect the sides of a triangle. So if you take a triangle and you kind of stretch and pull it, as you change the size of the triangle or the shape of the triangle, the angles will move and the sides will move. And trigonometry looks at how the angles interact, the size of the angles interacts with the size of the sides. And trigonometry is actually a huge area, and we're just going to focus in on right triangles for now. So in every right triangle, we have obviously a right angle, and there are three sides. One of them is longer than the others, and the reason it's longer than the others is because the right angle will always be the largest angle in a right triangle. The reason being, the angle sum of every triangle is 180 degrees. So if one of them is 90, then the other two have to be smaller than 90. Okay, and this longest side is called the hypotenuse. It's a weird word. It's Greek. Most of our geometry terms are Greek because the Greeks studied geometry really in depth. And I've looked into it, and I know it's a weird word, but it does sort of translate into English. And the translation is roughly an occupied toilet on a mountain. That is not your seat. Not you. Oh, you just didn't want to be marked here. I get it. That's cool. So, an occupied toilet on a mountain. Somebody will get it. No, nobody. Hypotenuse. What? A hypotenuse. Terrible joke. That was terrible. It's terrible. Okay, so the other two sides of a right triangle are called legs. It's finally almost did a flyby. So, because there are two legs in every right triangle, we sort of have to be a little bit more specific. Not sort of. We have to be more specific in how we label those. And so what we do is we pick an angle. And we don't pick the right angle because it's sort of always in the same spot. So we pick, let's say we pick this angle. And it could be called anything. It could be angle A or angle D or angle 7. But if we don't know what the angle's called, we just kind of call it theta. Theta is a Greek letter, kind of like pi, alpha, beta, gamma, delta, epsilon, zeta, eta, theta. And this is, I believe this is a lowercase theta. So it's just a letter in the Greek alphabet. And instead of referring to these as legs, we name them according to how they relate to the angle we choose. So H is always the big side every time. But when we look at the two legs, the leg that is next to theta, or the angle we choose, is referred to as the adjacent. Oh, adjacent. Okay? Adjacent just means next to. So to be lazy, we usually just call this A. And then the leg that does not touch theta is sort of opposite theta. So angle theta kind of opens up and creates this side that we call the opposite. All right? So every right triangle has all of its sides named in reference to which angle we pick. And we either call them adjacent, opposite, or hypotenuse. Well, what happens if I choose the other angle? So the A and the O switch. This is now A, and this is now O. Does that make sense? Does it matter which angle you pick? Not really. Sometimes one angle is a lot easier than the other, but it doesn't, in trigonometry, it doesn't matter which angle you pick. You can still do the mathematics if you pick the other one. Sometimes it's a lot harder, but you can still do it. Okay, so trigonometry mingles the size of an angle and the size of the sides. So if I were to take this, let's say I took this triangle, let's see if it'll let me do it, and I changed its shape. It doesn't look like it's going to let me. Okay. If I change its shape, you'll notice that the top angle, let's draw a better triangle than that. Okay. Look at the top angle. As I drag this down, what happens to that top angle? It's getting smaller. So as the left side gets longer, then the top angle gets smaller. If I move it in the other direction, what's happening to the top angle? It's getting smaller. So as the bottom gets smaller, the top angle is getting smaller. Well, all of that fit together is trigonometry. So the way we do this is we look at an angle and then we compare the lengths of two sides. How do you compare lengths? Well, you could subtract, but turns out that doesn't really make a lot of sense. Instead, we divide. So we look at this angle here and we say, what happens when we take the opposite side and we divide it by the length of the hypotenuse? Okay? So if I take O and I divide it by H, that kind of compares how big is O compared to H. And if I get something like 0.7, that means that O is 70% as long as H. If I get 0.1, that means O is 10% as long as H. Well, how many different ways are there to divide? Well, I could divide O and H, I could divide O and A, or I could divide A and H. So there are three ratios we're going to look at. Actually, there are six, but we're not going to deal with that right now. And sine. So every ratio has a name. We could have called them Edward, but we didn't. We could have called them Bailey, but we didn't. So we have named the ratios. What do the ratios do? Well, they connect an angle to a ratio. So the first one is called sine. S-I-N-E. Another one is called cosine. And the last one is called tangent. What do those mean? I don't know. They're Greek. They've been around for 2,000 years. That's just what we call them. But we're super lazy. We don't want to write all that out. So instead, we abbreviate them like that. Sine, cosine, and tangent. If you say sin and cos and tan, I'm afraid I'm going to have to laugh at you. So feel free. But nobody calls them that. Okay. Well, these have to be linked to an angle. So we always say the sine of theta, the cosine of theta, or the tangent of theta. And then those are equivalent to a specific ratio where you take one side and you divide it by the other side. So the sine is the opposite side divided by the hypotenuse. The cosine is the adjacent side divided by the hypotenuse. And the tangent is the opposite side divided by the adjacent. All right. Now, you need to memorize that. But it's not as hard as you think. Let's get rid of this. We have this little mnemonic. SOHCAHTOA. The sine is O over H. just like it says over here. The cosine is A over H. The tangent is O over A. So we pronounce that SOHCAHTOA, and the way you remember it, I learned something about an Indian chief named SOHCAHTOA. Anyway, I forgot it. It didn't make any sense to me. And then somebody gave me the magic mnemonic, which says, some old hippie caught another hippie tripping on acid. Yeah, you'll never forget it, right? Some old hippie caught another hippie tripping on acid. Piece of cake. What? Some old hippie caught another hippie tripping on acid. Okay? That's what they call it. That's the experience you go on when you're on acid apparently is called tripping. It's not actually falling down. It's good to know that you've never done that. Okay, so how does this work? Well, let's say I have a right angle or a right triangle. Even better that you don't know what that is. Good job, Ben. So, let's say I have a right triangle where the angles are labeled C, D, and E. Okay? And then I had side lengths of 3, 4, and 5. And then I asked you, what is the sine of C? So that tells us which angle to focus on. I'm going to focus on angle C. What two sides do I need to use for the sine? I need to use the O and the H. Does everybody understand that? Which side is O? 4. Which side is H? 5. So the answer is 4 over 5. Okay? What about the tangent of D? So I'm going to focus on angle D. I'm down here. And I need the O side and the A side. Because tangent is O over A. Which side is opposite angle D? 3. So 3. And which side is adjacent to angle D? 4. Okay. What about the cosine of C? Cosine is A over H. So if I look at angle C, which side is adjacent? 3. And then the hypotenuse would be 5. Okay, does anybody see a problem if we tried to do the sine of E? Why is that a problem? There's no O. If I pick angle E, then this would be the hypotenuse, and 3 and 4, they're both adjacent, and it doesn't work. So you can't choose the right angle as your angle. Now, there is more complicated trigonometry in the future that will allow you to do that, but it's not something we're going to learn right now. So when you do SOHCAHTOA, you can only pick those angles. You cannot pick the right angle because it turns out we have no O and we have 2 A's, and that's a problem. Okay. So, if I had this triangle and I wanted to know what is the sine of B, how would I get that? we have to use the Pythagorean theorem. So the Pythagorean theorem says a squared plus b squared equals c squared. That's a formula that goes for right triangles. What are a, b, and c? Does it matter? C has to be the hypotenuse. A and b don't matter. So 5 squared plus 6 squared equals c squared. So that's 25 plus 36 is 61. What do I do to the 61? Square root it. And I get the square root of 61. Okay. What is the sign of b? Well, sine is O over h. So we get 5 over the square root of 61. Does everybody understand that? Now, here's a tricky thing that's really annoying, but we have to do it. How many different ways are there to write the fraction 1/2? Many. What are some other examples? 2/4, 3/6, 4/8, 100 over 200. There are an infinite number of ways to write 1/2. So if everybody in the room had a different version of 1/2, what would we do to ensure that everybody ended up with exactly the same answer? We would simplify. Okay? Well, the same sort of thing happens with square roots. It turns out there are an infinite number of ways to write that fraction right there. But the rules of simplification say never leave a square root in the denominator. All right? And I know it's weird, but if you ever end up with a fraction like this, the fix is you move this to the top, so 5 times the square root of 61, and then you divide it by the stuff on the inside, which would be 61. And that ensures that everybody ends up with the same answer. Yes, so if your answer is 5 over the square root of 61, then don't plug that in. Plug in 5 root 61 over 61. So what if I had 6 over root 7? What would the answer be? 6 root 7 over 7. Okay, but watch this. What about 10 over the square root of 5? What would that be? 10 root 5 over 5. Does that simplify further? How many times does 5 go into 10? 2 root 5. So anytime you have a square root in the bottom of a fraction, move it to the top, and then write the number inside the square root on the bottom. Yes? Yeah. Yep. Let's do one of those. All right, what if we have 8, 4, A, and B? How do I figure out this side? Pythagorean theorem, a squared plus b squared equals c squared. Which one am I missing? A or B? Doesn't matter which one. So 4 squared plus b squared equals 8 squared. 16 plus b squared equals 64. Subtract 16. B squared equals 48. Square root. And we have to simplify the square root of 48. Do you guys remember how to do that? Factor it. 2 and 24, 6 and 4, 2 and 3, 2 and 2. We cross off anything that's simplified. What are we looking for? Pairs. So I have a pair of 2's and a pair of 2's and a 3 left over. So the first pair brings out a 2. The second pair brings out a 2. So what's on the outside? 4. And did anything stay on the inside? Root 3. So this is 4 root 3. Okay. Now, I want the sine. Let's say I want the sine of A. What would the sine of A equal? Well, sine is O divided by H. What side is O? 4 root 3. What side is H? 8. Does that simplify? Well, 4 over 8 simplifies to be 1/2. So it's just root 3 over 2. Okay. What about the cosine of A? What will the cosine of A equal? So A would be 4 and H would be 8. So 4 divided by 8 becomes 1/2. Okay, last one. What about the tangent of B? So tangent is O, which would be 4, divided by A, which would be 4 over root 3. How do we fix that? So let me write that a different way. 4 over 4 root 3. Well, the 4's cancel, right? So I get 1 over root 3. I can't leave that in the bottom. So I move the root 3 to the top. I move this to the top, root 3, and then I put this on the bottom, root 3 over 3. Okay, let me look at your assignment, make sure I covered everything. Okay, so that one you just do sine, cosine, and tangent. Oh, these you just plug into your calculator, but you have to make sure that your calculator, there's a rad button or a deg button. There are actually 2 ways to measure angles, and we know how to measure angles in degrees. So these problems will only work if you use the degree version of your calculator. So it should, on the screen somewhere, it should say radians or degrees. You need to find the degree button and make sure that that's the one that's turned on. All right. And then number 3. This is where you use the Pythagorean theorem to find the missing side, and then you can answer the tangent of theta. So for this problem, I need to figure out what, let's call this A is. So A squared plus 8 squared is 17 squared. A squared equals 64, or sorry, A squared plus 64 equals, I don't know what that is. What's 17 squared? 289? 289. Then I subtract 64. And that gives me 225. When I take the square root, what is the square root of 225? Not 5, it's 15. So A is 15. If this is my angle, how would I find the tangent? O over A, which side is O? 15. Which side is A? 8. So my answer is 15/8. All right? Those are the 3 problems types that you have to do. Get to work.